Hey guys, in this video we're going to talk about the different types of chemical reactions that there are. On your reference sheet, next to the formulas list, are these different types of reactions. And it gives you kind of their basic formulas, and then for some special cases, it also gives you how some things will combine together and split apart. The first type of reaction we're going to come across are combination or synthesis reactions. This is where you have two or more substances. A lot of the times they're going to be two elements, and they are reacting to form a single new substance. So the general formula that's given on your reference sheet is this A plus B produces AB. And I just have a couple examples up here. If we have magnesium plus oxygen, they'll combine to produce magnesium oxide. Note, whenever you combine them, you do have to crisscross charges whenever it's that ionic compound. Same thing, sodium plus chlorine produces sodium chloride. Hydrogen plus oxygen can produce water. So whenever it's a synthesis reaction, a lot of times it will start with two elements. It can start with a compound, but majority of the time you're going to see it with two elements at the reactant side, and it's going to have one product. Our second type of reaction is the opposite of synthesis. This is decomposition. So decomposition reactions are where you have a single compound, so a single reactant that is breaking up into two or more products. The general formula given on your reference sheet is this AB splits into A plus B. If this is a binary ionic compound, it will simply split into the elements. If it is not a binary compound, there are special cases that are listed below, and we'll go through those in a little bit. So for example, we have mercury 2 oxide. That will split into mercury and oxygen. Note that if it splits into a diatomic molecule, you need to make it diatomic. We also have water. You can run electricity through water and split it into hydrogen, oxygen. This is one where it's going to use one of those special formulas that's listed below under decomposition. We have calcium carbonate, and it tells you that carbonates split into the metal oxide and carbon dioxide. So that will split into calcium oxide and carbon dioxide. Our third type of reaction is a single replacement reaction. In this one, you're going to have an element that's by itself that's trying to replace another element in a compound. So the general formula for it is this A plus BC. So single letter is your element, BC is your compound, and that's going to produce B plus AC. If the element by itself is a metal, it is switching with the metal in the compound. If the one by itself is a nonmetal, so most of the time it's going to be a halogen, it will switch with the nonmetal. So here's an example. We have copper and silver nitrate. Copper is switching with the silver, so that will produce silver and the copper 2 nitrate. Or we might have potassium and water. So potassium is switching with the positive hydrogen, so that will produce hydrogen and potassium hydroxide. In double replacement reactions, here we have two different compounds that are exchanging their positive ions to form two new compounds. So everybody is switching partners here. The general formula given on your reference sheet is this AB plus CD. If you note, the A and the C are going to switch places. So it will become AD plus CB. And note that they don't have to go in order, but whatever that positive ion is, that metal always is listed first. So we have lead 2 nitrate and potassium iodide. The lead and the potassium are switching places, and that will produce lead 2 iodide and potassium nitrate. Whenever you're making new compounds, you always want to make sure to crisscross those charges. And with transition metals, they are going to keep the same charge from one side to the other in these cases. Another example is calcium carbonate and hydrochloric acid. The calcium and the hydrogen are switching places. So it will make calcium chloride and carbonic acid. A type of double replacement reaction we'll come across are acid-base reactions. Whenever you have an acid, so something starting with hydrogen, and a base, so something ending in hydroxide, they will always combine to make some kind of ionic salt in water. So actually how we make table salt is they'll mix hydrochloric acid with sodium hydroxide. The H and the OH are going to pair together to make water, and the sodium is going to pair with the chlorine to make salt. And note, this happens to be table salt, but any type of ionic compound is considered a salt. And our last type of reaction we're going to go over is combustion. In combustion reactions, you have substances that react rapidly with oxygen to produce heat and light. So these are small explosions, depending on how much of a sample you have. Note that oxygen will always be listed as a reactant. So anything that has pure oxygen, O2 is a reactant, technically is a combustion reaction. But some of them can behave like synthesis reactions. Most of our combustion reactions contain hydrocarbons. So this is a compound with some form of hydrogen and carbon. Sometimes it may also have oxygen or something in there as well. But combustion reactions with a hydrocarbon always produce carbon dioxide and water. This is listed on your reference sheet as well. So an example, our gas jets in the lab have methane gas. So methane and oxygen react to produce carbon dioxide and water. These are those CHO reactions that can tend to be hard to balance. So we're going to switch gears and look at how to predict products using those rules that are listed on our reference sheet. So we're just going to look at the synthesis reactions and decomposition reactions in this video. The other types we'll look at tomorrow. So with synthesis reactions, remember you are following that pattern of A plus B gives you AB, is that general pattern. This is fairly easy whenever you're using ionic compounds because they crisscross charges and they can only make one type of substance. However, whenever you only have nonmetals reacting or you have transition metals that are reacting, it's possible that more than one product can be made. Because remember, molecular compounds, even though they have the same elements, they might have different subscripts. So here we have listed where we have sulfur and oxygen. One of them makes sulfur dioxide, one makes sulfur trioxide. With transition metals, remember they can have multiple charges, so they can make multiple substances. So let's look at a couple examples of synthesis reactions together. Note that all of these start off with two elements, so it's going to be easy to know that it's synthesis. So our top one, we have calcium plus nitrogen. So when they combine, it's going to be calcium and nitrogen. Because this is ionic, we have a metal and nonmetal, we need to crisscross our charges. Remember, calcium has a charge of positive 2, nitrogen has a charge of negative 3. So whenever we crisscross, it will be Ca3N2. That's the only possibility that it can make because it's ionic. The second one, we have iron plus oxygen. So when they combine, it will be iron and oxygen, but we have to crisscross charges. So remember that iron can either be a +2 or a +3 charge. So there will be two possible answers depending on which charge you go with, unless you're told which charge it will turn into. So the first one we'll look at is if we have iron 2, if iron's a +2 and oxygen's a -2, it will stay FeO. Whereas if we're dealing with iron 3, if iron is a +3 and oxygen's -2, it will be Fe2O3. So unless you're told which charge it changes into, either answer is appropriate. Look at our third one. We have hydrogen plus oxygen. Here we have two nonmetals, so there are multiple answers of what it can form. This can commonly form water, or it can form that hydrogen peroxide that we talked about yesterday. Pretty much as long as you have hydrogen and oxygen together, it would be an acceptable product. Whereas look at our last one. We have magnesium and sulfur. So when they combine, you have to crisscross your charges because it is ionic. Magnesium is a +2, sulfur is a -2, so it will simply be NGS. So pay attention and make sure to crisscross those charges when appropriate for synthesis reactions. All right, let's look at decomposition reactions. These can be a little bit trickier, but this is actually what is listed on your reference sheet. So it tells you that if there's like a capital M, it stands for metal. Capital NM stands for nonmetal. You were given the base formula of A plus, or AB splits into A plus B. That's if it is a binary compound, whether it's ionic or molecular. So if there's only two elements, it's going to split into the elements. Where it gets a little bit trickier are all the ones below. Whenever you have polyatomics and stuff like that, they are going to split apart differently. So for example, B, if you have some kind of carbonate, this one we looked at in the examples given, it will split into the metal with oxygen and carbon dioxide. For C, if you have a metallic hydrogen carbonate, it will split into the metal with carbon dioxide plus water plus carbon dioxide. So everything is going to be standard, but you need to make sure to crisscross charges in those formulas that have the metals. If you have some sort of base metallic hydroxide, it will split into the metal with oxygen and water. If you have metallic chlorate, it will split into the metal with chloride and oxygen. If you have some sort of acid, it will split into the nonmetal with oxygen and water. So for these, you're not expected to memorize the patterns because they're on your reference sheet, but you should be able to use them whenever you're asked. So let's look at some examples of these. So our first one, we have CuO. So whenever we just have a binary compound, it is going to split into the two elements. So it will split into copper. And note that we're not going to bring the charge over with copper because copper is going to be by itself. So it will end up being a solid. And it's also split into the oxygen. Remember, oxygen is diatomic, so make sure to make it so whenever you split it apart. And then we could balance this from here. Our next example with calcium carbonate. I'm going to go back to our rules for a moment. It tells you that if you have a metallic carbonate, we're looking at rule B, it's going to produce the metal with oxygen and carbon dioxide. So the metal with oxygen would be calcium with oxygen. Make sure to crisscross your charges. They're a positive 2 and negative 2, so that would stay as is. And carbon dioxide. For the third one, we have sodium hydrogen carbonate. Let's go look back at our rules. It tells us that if you have a metallic hydrogen carbonate, splits into the metal with carbonate, water, and carbon dioxide. So the metallic carbonate would be sodium carbonate. Remember, sodium is a positive 1, carbonate's negative 2, so it'd be Na2CO3 plus water plus, we said, carbon dioxide. So use those rules religiously when you're doing these. For our last one, we have sodium sulfide. It is a binary compound, so it will simply split into the two elements, so sodium and sulfur is not diatomic, so we can leave it as is. That's all we're going to do in this video. We're going to pick up with predicting products in the next video, starting with single replacement.